quadrant 1, is that angle positive that I've drawn? Yeah, because it's going counterclockwise. Is it acute? Yeah, because it's in quadrant 1. So if it's an angle in quadrant 1, I don't have to do any work. It is positive. It is acute. It is a reference angle. So any of those angles in quadrant 1, you don't have to do any work. Okay. But in the other quadrants, you're going to have to do a little bit of work. So I'm going to draw an angle in each quadrant. So here's going to be my quadrant 2 picture. So if you want to draw a quick sketch, it's an easy sketch. Just make a coordinate plane. Do initial side on the positive x-axis. And then plot your terminal side anywhere you want in quadrant 2. So terminal side in quadrant 2. Okay. This is going to be my angle theta, which now in quadrant 2, theta cannot be a reference angle because while it's positive, it's more than 90 degrees. It's not acute. So then I have to rely on the second part of the definition that the reference angle is formed by the terminal side, so that's this side right here, and the horizontal axis. Now the horizontal axis is the full x-axis. You know, I could go to the positive, but then I'm more than 90. So it must mean that in this quadrant 2, I have to be going back to the negative. So that angle right there, that's theta prime. That's your reference angle. The terminal side to the horizontal axis, and it's acute. Now you might recognize this angle like if you had plotted a point over in quadrant 2 from yesterday, we would draw the line back down to the horizontal axis so that it was part of our bow ties. And then the angle was right there in this green triangle. So we were actually using the idea of a reference angle without you knowing about it. Okay, now think back to geometry. You got a name for those two angles, theta and theta prime, based on the picture you see? What are you going to say? How are they related to each other? Are they complementary? Or supplementary? They're supplementary because complementary angles add to 90 and supplementary angles add to 180. So another phrase that you might use for these two because they're adjacent supplementary angles is a linear pair. They're right next to each other and they form a line. They form 180 degrees. Okay. The reason why I point that out is if you're trying to find theta prime, and you know what theta is, it's like trying to find its supplement. So if you're trying to find the supplement of an angle, you subtract that angle from 180. Right? So if you want to know what theta prime is in quadrant 2, do 180 minus theta. And of course, I'm going to put up a rule here. What if it's in radians? Then we'll do pi minus theta. Now, certainly one avenue to being able to answer these questions on a quiz or a test is memorization. Ugh. The second avenue, which I think is the better avenue, is recognizing like, okay, it would form this picture of a linear pair or supplementary angles, and I would subtract from 180 or pi. All right, draw yourself a picture of an angle in quadrant 3. So again, obviously theta, the red angle, does not fit the definition of a reference angle because it's way over acute. Okay, it's more than 180 now, isn't it? So we would think about, okay, what does the reference angle look like in quadrant 3? It's formed by the terminal side and the horizontal axis. You could go either way to the horizontal axis, but only one way is acute. If I go to the negative side, right? Okay. So my reference angle in quadrant 3 is this angle right here, which again, think about yesterday's homework. If you had a point given to you in quadrant 3, you would draw this triangle back to the horizontal axis. Now I'm going to give you an example for this one. What if I said that this red angle was 250 degrees? And I wanted to know what just the green angle was. What would you do? Chase?
I would subtract the 250 from 270.
Ooh. 270 is here. If you subtract all the 250, you're really finding
That, right?
that angle. That's not the reference angle, though.
Right, so instead you would probably subtract the... Now I'm confusing myself.
Yes, I know.
Hold up.
Okay. Hang on. Give him a minute. So if this whole thing was 250, how would you find just this bit right here? You don't care about quadrant 1. You don't care about quadrant 2.
Would you subtract 180 from it?
And they add up to 180. So there's a whole 180 degrees you're not interested in, isn't it? I often think about in quadrant 3, I think about like an overflow. It's beyond the 180. They already made the linear pair. Okay, so it's like the overflow. What's the extra? So you better write this into your notes. Theta prime is theta minus 180. Now, Chase, I'm actually really glad that you said 270 minus theta because like that's an easy thing for us to think we should do, or use the 90. But remember, we're focused on these like bow tie angles. I stress that a lot. And bow ties, if you're going back to the horizontal, they're going to involve 180 and 360. So you're kind of stuck with those two numbers. You should never be using the 270 and the 90 for reference angles. Okay, at this point, I think you could probably draw your own picture for quadrant 4. So go ahead and draw your picture for quadrant 4. So now this angle is even bigger than 270. When we move over into quadrant 4, then our reference angle is formed by the terminal side and the horizontal x-axis, so that we create the acute angle. That would be now the positive side, right? So theta prime is that small angle right there. Remember, don't go back to the y-axis because that makes an hourglass, not a bow tie. So we need bow ties only. So what do you notice about the red and the green angle together? They make what, Alex? They make the whole circle. They make 360. So kind of like this one, when you know that they add up to 180, you're going to subtract from that. So theta prime is 360 degrees minus theta, or theta prime is 2 pi minus theta. Again, one avenue is memorization. It's not my favorite because then once you've learned it, crammed it, used it, you dump it. And next year you're going to be asked to use the reference angles again. So if you can sort of like imagine these pictures and think about, okay, in quadrant 4 they make a whole circle. In quadrant 3 it's an overflow, so I got to subtract those first two quadrants, 180. In quadrant 2 I'm creating a linear pair. It's supplementary. That's going to stay with you longer than the things at the bottom of the screen. Okay, but you will have to do whatever works for you. Now I do have some disclaimers for these statements at the bottom of the screen. Okay, so to use all of these, it's only if theta is in a specific range. So if I want to do like 180 minus theta, any of these things, theta needs to be between 0 and 360. And if it's in radians, it needs to be between 0 and 2 pi. So it's only for those thetas. I say that those angles are like angles within one full revolution of a circle. If you get an angle that's not in that range, use a coterminal angle. So now we're seeing the benefit of being able to name angles that are the same angle with a different measure, because then we can sort of apply this reasoning. So if you have a negative angle, you can't use those rules. 180 minus a negative angle, you wouldn't actually be subtracting, you'd be adding, and that's not going to get you an acute angle. You would add 360 until you get something between 0 and 360. Or if you have something more than 360, subtract, so it's within that range. Okay, so that you get the positive and the acute angle. So I'll do some examples. We'll start with some easy ones. Okay, 260. Theta equals 260 degrees. Here's what you're going to do on the homework. Sketch it. Find its reference angle. Well, sketching 260 shouldn't be hard. What quadrant is your terminal side going to be in? Quadrant 3. Probably close to 270, right? So you got it sketched. You're going to find the reference angle, theta prime. Now in quadrant 3, your reference angle is the overflow of 180. It's how far past 180 you went. You haven't gone all the way to 270. So you take your angle, 260 degrees, and you subtract 180. So theta prime, our reference angle is 80 degrees. That's this little piece right here. 80 degrees. It's only 10 degrees left to get to 270, so it would make sense because then that reference angle is a complement to that 10 degrees because they make 90. Is 80 positive? Yes. Is it acute? Yes, so it's an okay reference angle. Okay, don't give me any reference angles that are negative, and don't give me any reference angles that aren't acute. Okay, another easy one. Theta equals 7 pi over 5. Okay, can you sketch it? Can you find the reference angle? All right, 7 pi over 5, so 7/5 is improper. It's more than 1 pi. And then we have 1.5 pi. Is 1 2/5 more than 1.5? You have 2/5. No, you haven't made it to a half yet, have you? Half of 5 would be 2.5. So this one must also be in the third quadrant. Yes?
We don't have to be too specific in the graph ratings.
Right quadrant, yeah. So if it's closer to the other axis, it's not a big deal to me. Okay, and then find my reference angle. Theta prime equals, this is again the overflow, so I take the larger angle, 7 pi over 5, and now I'm going to subtract just 1 pi, right? Just the two quadrants that I don't care about, so I'm going to subtract pi from that. I can subtract 1 pi from 7/5 pretty easily, just in my head. 5/5 would be 1, so it's 2/5 pi. If you need to, you can get common denominators. That is 7 pi/5 minus 5 pi/5 if you need to write it down. So it's like pi over 1, and then you could multiply top and bottom by 5. 5 pi over 5. But you'll get 2/5 pi either way. Now 2/5 is positive, and you can tell it's acute because it's less than half. 2 out of 5 is not having half of something. If I had $5 and said I was going to share it and only gave you 2, you would wonder why you didn't get 50 cents. Okay, so one more to do. What would you do if your angle isn't between 0 and 360? Or let's say 0 and 2 pi. So if I give you theta equals negative 740. Uses coterminal angle. So because it's negative, I know I'm going to be adding rotation. So let's add 360. Okay, that's still negative, right? So let me add 360 again. Does anybody know what 360 and 360 together make? 720. So wouldn't negative 740 plus 720 be a negative 20 degrees? Okay. Now I just want to point this out. Is that positive? No. Is it acute? Yes. If you ever notice this, that while you're doing coterminal angles, that you get a negative acute angle, its reference angle is automatically the opposite. So like I know this. I know that theta prime is positive 20 degrees. It's not negative 20 because the reference angle isn't negative, but it is positive 20. Now, if you don't necessarily always believe that, then you could say, well, let me keep going, right? Add another 360 and I've got 340. 340 is in quadrant 4. And to get the reference angle, remember in quadrant 4, it's the whole circle minus the angle you don't care about. So 360 minus 340 is 20 degrees. Okay, so it will always work like that, that if you add another one, you'll get a really big angle in the 4th quadrant, and then you'll subtract it from 360, and it'll just be that positive version of your negative acute angle. So if you recognize that, that's kind of like one little shortcut that you can take. Okay, one last thing. I've got a little piece that I want to give you for your notes. It's got some angles on it. Let's see, where did I put it is my question. Here it is. Okay, let's see. Izzy, you guys want to grab that tape on that desk? Let's see, where did I put my other tape? Oh, yeah, grab one of those, Alex. And Dan, you want to grab the other one that's on my corner of my desk? If you want to take this somewhere in your notes, we're going to use it a lot tomorrow too. Okay, so what I've handed out to you are the special angles. So if you want to label those special angles. And before, like we've talked about special right triangles, you might recognize those angles over here in quadrant 1, right? 30, 60, 45. So obviously the special angles are from the special right triangles. In the other quadrants, there are more special angles, but now like 120 can't be in our special right triangle because you can have 90 and 120 in the same triangle. But 120, 135, and 150 are also considered to be special angles because their reference angle is 30, 45, or 60. So like 150 is really 180 minus 30. So the 150 angle has a reference angle of 30 degrees. It's that small one right there. And then the 135 is special because it's 180 minus the 45 degree angle. Is 135, and that gives us this angle right there. That's 45 degrees. So that's like that triangle you would draw back to your horizontal axis. That's the same triangles on the back wall of the classroom. And 120 is special because it's 180 minus 60, and that's the big angle, right? That's the 60 degree angle there. So those are considered special because they come from the special right triangles. How am I getting the angles 210, 225, and 240 in quadrant 3? Why are they special? Chase?
If you subtract 180 from each angle, it would give you 30, 45, and 60.
Okay, so if you did the reference angles for each of these, 210 minus 180 is 30 degrees, 225 minus 180 is 45 degrees, and 240 minus 180 is 60 degrees, right? If you're trying to if you're trying to find out what those angles are, this angle 210 is 180 plus 30. That's why it's special. We added the reference angle to it. This is 180 plus 45, and this is 180 plus 60. So if you ever forget what the special angles around the circle are, you're really just going into the quadrants and applying the reference angles. How would you be getting quadrant 4 angles? 330, 315, 300. Subtracting from the 360. Now we're working off of this positive, so this is 0, but also 360 degrees. So this one is 360 minus 30, 360 minus 45, and 360 minus 60. It seems like such a tiny thing, but this is huge. The sooner you get familiar with these angles, the happier you're going to be. Because if you can recognize that 240 is automatically a 60-degree reference angle, you have way less work to do. So we'll be spending more time with this circle tomorrow, but I just want to put those out there that these are what we call special angles. And they're all special because they come from the 30, 45, 60s, right? You're either adding, subtracting from 180 or subtracting from 360. Your homework assignment is page 482. It's the last book assignment before the set of worksheets that we're doing. So if you've been confused because of snow days, it's 482.